Here's an example of dividing two polynomials. Before you start working on division of polynomials, be sure you really understand how long division of integers works, because dividing polynomials is very similar. Alright, so here's our example, 4x squared plus 8x minus 14 divided by 2x minus 2. So we're going to set up our long division for polynomials just like we would for integers. Our divisor, the bottom of our division, goes over here, 2x minus 2. And then in this sort of weird brackety thing, we put our numerator, it's called the dividend, 4x squared plus 8x minus 14. Alright, so just like for integer division, we ask ourselves what times 2x would give us the first part of the dividend. So what times 2x is 4x squared? And that's going to be 2x. And now we multiply. 2x right here times 2x minus 2. And we write the result of our multiplication over here. So 2x times 2x is 4x squared. And then 2x times negative 2x is minus 4x. And then, just like with integer division, we subtract. Alright, so when you're subtracting, remember that this minus sign distributes like this. So it's going to make this 4x squared a negative, and it's going to make this minus 4x a positive. Okay, so 4x squared minus 4x squared is 0x squared. So right here, there's no x squareds left. That should always happen. The whole point of this long division algorithm is that at every step, the biggest part that you have left should cancel completely. So the fact that there's no x squareds left is a good sign. This means that when we chose 2x up here in our quotient, that was the right choice. So no x squareds left. And now 8x plus 4x is 12x. And then minus 14 plus, there aren't anything, there's nothing in the ones place here, so it's just minus 14. And now we ask ourselves, are we done? You're done with your division when the remainder is smaller than the divisor. And when we're talking about polynomials, smaller means lower degree. So our remainder has degree 1, our divisor has degree 1, so the degree of our remainder is not smaller than the degree of our divisor, so we need to keep going. So now we do the whole thing again. We ask ourselves, what times 2x is 12x? And that would be 6, so we need to plus 6 right here. So 6 times 2x is 12x, and 6 times negative 2 is negative 12. And then we subtract. Remember that this subtraction distributes. So this 12x is really negative 12x, and this minus 12 is really plus 12. 12x minus 12x is no x's. And again, that is a check that when we chose 6, we chose the right thing because our x is canceled. And then negative 14 plus 12 is negative 2. And now we check again, are we done? To check if we're done, we look at our remainder, negative 2. The degree of this remainder is 0 because there aren't any x's there. And the degree 0 in our remainder is smaller degree than our divisor. So that means we're done. So now we can write our final result. And just like with integer division, your final result is the quotient, this piece right on top. So 2x plus 6 plus the remainder, this minus 2, over the divisor. So the remainder is negative 2 over the divisor is 2x minus 2. All right. So this is our final result. Well, almost our final result. In this remainder piece, we can actually cancel a factor of 2, since in the numerator everything is divisible by 2, and in the denominator everything is divisible by 2. We can cancel a factor of 2, and when we do that, we get the 2x plus 6 isn't changing, and this minus sign right here, I'm going to bring that down in front and change that addition to subtraction. Now when we cancel a factor of 2, all these 2's get canceled, and we're left with 1 over x minus 1. So there's our final result, 2x plus 6 minus 1 over x minus 1. So just a reminder, if you ever get lost when you're doing polynomial division, just think of integer division and ask yourself, what would you do next?